Hello, I'm Steve Hughes. This presentation is about the sandworms of Arrakis. We will look at whether or not they could exist, as described in Frank Herbert's sci-fi masterpiece, Dune. To determine whether the sandworms could exist, we will examine the scientific reasonableness of 5 aspects of the worms. They are compared with life on Earth to determine if it is possible for the worms to exist as described or not. The aspects are surface to volume ratio, pressure under the sand, the existence of the spice melange, a planet of sand, and food for life underground. On the left, we see the size of several animals that have lived on Earth in meters, starting with humans and ending with the largest known animal, the blue whale. In the book Dune, Herbert describes Shai-Hulud, the largest of the sandworms, as being half a league long. That's 2,778 meters. On the graph to the right, we see Shai-Hulud compared to the same Earth animals. The sandworms of Arrakis are not just big, they're huge. This creates a problem considering what we know about energy expenditure and heat. The worms are described as burrowing through the desert sands at great speeds. The Fremen used the worms to travel across great distances on the surface of Dune. Such energy expenditure creates heat. As the size of an object increases, the volume increases at a greater rate than the surface area. This means that as the worm gets larger, there's less surface area for the heat to dissipate across. This is a real problem that is not addressed by Herbert. Such a huge creature would have to have a very slow metabolic process, very different from the active sandworm described in the book. Or there would have to be some other cooling mechanism which is not explicitly described. The pressure of burrowing under sand may seem like an obstacle for the worms, but we see examples of this right here on Earth. To the right are tube worms, which live at the bottom of the Marianas Trench. The pressure is 8 tons per square inch, 1,000 times the pressure at sea level. These life forms show us that life is possible even at very great depths. The spice, described in Dune, presents a problem for scientific reasonableness. Frank Herbert describes the spice as giving prescient vision to some who ingest it. Paul Atreides, the Kwisatz Haderach, can see many paths into the future. This goes against our scientific understanding of the nature of time. This could be explained, however, if what the characters of the novel are experiencing was just a powerful hallucination. Things that are explained as prescient vision could have just been lucky guesses combined with subconscious thought. And not every character who ingests the spice is described as having future sight. Where does the melange spice come from? It's clear from the book that it's part of the life cycle of the sandworms, but there's much left to the imagination. It could be a waste product from the worms. It could just as easily be a waste product of a symbiote of the worms, living beneath the sand. It may even be part of the reproductive cycle of the worms. We just don't know because the book doesn't say. Is a desert planet realistic? Yes. There are powerful erosive forces described in the book. Sandstorms powerful enough to disintegrate bone and metal. Not just wind erosion either. Liquid water is described as existing on Arrakis underneath the sand. And of course, the massive worms themselves would erode the environment as they burrow through it. What would a giant worm eat? The surface of Dune is described as nearly lifeless. So what would these massive worms eat? To answer that question, we should look again to the Marianas Trench. There we see that sulfur-oxidizing bacteria live off the minerals expelled by volcanism on the ocean floor. There is nothing to suggest that a similar process could not take place under the sand, with what Herbert calls little makers shepherding water down to active volcanoes where blooms of bacteria could then form. The sandworms could then eat the bacteria. If blue whales can survive on krill, it's plausible that sandworms could survive on bacteria. This is the idea proposed by Kevin Grazer in his book, The Science of Dune, which examines the science behind Dune. Could life evolve on Arrakis? For life to exist, there must be liquid water. Arrakis has liquid water. There must be carbon. Arrakis has carbon. And there must be an energy source. Arrakis has many energy sources. So yes, life could evolve on a planet like Arrakis. While some form of life could evolve on Arrakis, it is not scientifically reasonable to think that sandworms would evolve. Two main points stand out as huge scientific roadblocks to such a creature. First, that the surface to volume ratio would not allow for such an active worm to maintain its body temperature. Second, that it is impossible, given our understanding of time, to see into the future. And in Dune, the worms are part of an ecosystem which makes the spice, which allows for future sight, which is not scientifically reasonable. As cool as it would be, this life form is just not possible the way that it is described. If you're interested in learning more about the ideas presented here, please see these references: the novel Dune, the astronomy textbook, and The Science of Dune by Kevin Grazer. Thank you very much for watching. I hope you found this presentation enjoyable.